Today we learn about networking. Networking technology is one of the last chapter in your CS2 course and has a weightage of 12 to 15 marks depending on your choice. So this is completely a theoretical subject, but lots of things to understand conceptually. So if you understand the concept of networking, you will easily remember the things which you need to write down in your exam. You know, to just mug up the things. So let's start with this. Basically, networking can be defined as when there are two or more computing devices connected to each other. It is networking, computer network, right? Examples I have tried to give based on day-to-day life. We use lots of networking. Let's see how. That you have a computer lab maybe in your school or computer class. There are 10 to 15 computers connected to each other through some means, maybe through wired or wireless network. And there is a printer connected to one of the computer, and rest of the users can send print job to this printer. So this can be useful to save the cost of 9 printers. Each of this individual user need not to have printer. They can share a printer which is connected to another computer which is part of the network. Then maybe when you share the files from your mobile with your friend's mobile through some applications and protocols like Wi-Fi or Bluetooth, this is also networking. Another example can be a company having 3-4 floors building. Each of the floor has maybe 100, 150 computers, and these floors are connected to each other to share resources. Maybe you want to share the files with your colleagues working on the same project. And it can be a school campus where there are different buildings, computer lab or admin building or different classes, and they are all connected to each other. This is also networking. Another example can be when you withdraw money from ATM. ATM machine basically doesn't have your details about your accounts, that how much balance you have. Once you insert your debit card, it will go to the server located far from ATM. Maybe if we are in India, it could be in Delhi or Mumbai, maybe in US also. So this will get the details from that server and allow you to withdraw money from local ATM machine. This is also an example of networking. When you pay some money through Google Pay or Paytm or internet banking, then also you use networking. You store some files as a backup to your Google Drive where you have space on the cloud, some storage space on the cloud which is far from your PC, and it is already automatically synced to G Drive. That is also networking. Then when you purchase anything online, maybe shopping, e-commerce sites, this is also networking because you are part of the large global network internet, and then you use facilities like browser to connect to those servers. Then when you make payment through debit card or petrol card for anything, this is also networking. When you play games with your friends, which friends are not sitting in the same premise, then also it is networking. We come across in daily life lots of things which use networking. So computer networks, you can get questions like goals of networking, uses of networking, advantages of networking. These are the common questions it may be asked in the exam, but more or less it will be same answer. That first of all, networking started with sharing the resources. Sharing resources means resources can be file, folder, it can be hardware like DVD, ROM, or it can be a printer. It can be intangible things like bandwidth can be shared. You can have only one internet connection in your school and all the students will share the same connection. So this is resource sharing. Basically it saves the cost in some cases. For smaller network, it justifies the cost saving. Then second is save the cost, as we discussed, that but most of the cases it doesn't happen, because for larger network it is more about not saving the cost, it's more about managing the customers, managing users, controlling users. This is more important than saving the cost. So for yes, but for smaller network it's save the cost. Like we discuss about, you have 10 computers and one printer, you save the cost of 9 printers. That's how it saves the cost. You have one internet connection and 100 users in the school, or 5,000 students in the school, and use Wi-Fi facility, that's where it saves the cost. Then it can connect to your networks, access to files and data through remote access. So you can access computers like this from remote. And maybe call center guys, if you have heard about call centers and BPOs and KPOs, they make voice calls, then take remote of the remote computer which is located maybe in US and fix the problem. So here the facility is, you can easily access a remote computer through internet, through some tools like AnyDesk and TeamViewer, and lots of other tools are there. Online learning through Zoom or different apps like Microsoft Meeting and lots of other softwares. This also uses networking. So you can get access to remote database easily through networking. You need not to physically visit the place, and you can get access to those databases. Then it is a high reliability. High reliability basically is about that I have primary computer which is very important, like web servers, email servers, database servers, or file servers. Suppose all my files or my emails are located here in this farm, and you will create a mirror copy of this farm, that this is a primary computer, this is secondary computer, maybe a server, this is my primary mail server, this is secondary mail server. You must have noticed that when you access your Gmail account, hardly you will find that Gmail service is down. That is because not that this primary computer is always working, but you have a second copy which automatically takes over the job once this fails, right? So this is how networking offers you high reliability and availability, you can say. So you can have even this things placed at distance place. Maybe my primary server is in Mumbai, secondary server maybe in US. Doesn't matter, right? So these are more mainly for advantages, uses, and goals of networking to achieve. Networks in communication, like how many networks it can be defined or categorized as the different types of networks like LAN, MAN, WAN. There are others also like personal area network, which is PAN, campus area network, CAN, right? So we'll discuss about these three major categories. LAN is about local area network, where it is one single premise only located within the premise. Like in a school campus, you have 3 4 buildings, each of the buildings are connected internally through maybe some wireless means or fiber optic cable. But here the important thing is they are in single premise. Computer lab or maybe a small company. So number of computers are also limited, that 10 to 1,000 computers. Nowadays more computers also can be connected. Technology has evolved and changed, so it allows you to connect more computers also. It is normally within the distance of 10 kilometers. Like you have a university campus or acres of land, and there are different buildings, different departments connected to each other internally. This is also local area network, LAN. One more important thing about LAN is ownership lies with the company. That I can decide as a management of school, I can decide that how much bandwidth I want to offer to my students, which type of access I want to give to the students, or how many of them should connect, how many of them should not connect. This can be decided by company, and it's the ownership of the company. So complete network is set up by school itself or a company itself, and there is no dependability on service providers. Like I need not to depend on Reliance or Airtel or Tata to give connectivity between two buildings in my school campus. I can simply lay cable of the required bandwidth, like fiber optic cable or wireless devices I can put up, and these devices are my own devices. So company ownership of LAN lies with the company. No service providers required. No dependency on service provider, we discussed. More faster as compared to MAN and WAN. Because in MAN and WAN we will see that network bandwidth is normally purchased from service providers, and we try to limit the bandwidth. Like in our home premises also, we buy internet connection. It's a broadband connection maybe of 20 Mbps. If you ask for higher bandwidth, normally they will charge higher. So LAN bandwidth, there's no dependency, so you can choose. It is one time investment for school or company, that once the cable is laid for 1000 Mbps or maybe more than that, this bandwidth will be available for users in the campus. So it is more faster compared to MAN and WAN. Then second option is metropolitan area network. This is basically located within city limits, has distance limit up to 20-25 kilometer. You have a manufacturing unit outside the city limits, and you have marketing office within city area, and you want to connect this to that. You want to see that how much manufacturing is done, what kind of products are being manufactured here, what quality of product being manufactured here. Sitting in the city office, you want to see this, or you want data of all these things, that how much material is consumed, what is the inventory there. You want to check updates not by visiting physically, but you want to see from your city office only. Then you can connect this to premises, which is itself LAN individually in itself, and when you connect these two, it becomes metropolitan area network. Good example of MAN is a cable TV network. Cable TV network people, they give you connections for internet or TV or lots of other services within particular city limits, right? But there is a dependency on internet service provider ISP, that you will have to request, because you are not allowed to dig the roads. And there are companies like Reliance and Tata, they have already laid the cables across country, and they can give you connectivity between any two stations which you ask for. So it is comparatively slower, as we discussed, compared to LAN, because we have choice to select the bandwidth. But here you are dependent on service provider. So if you ask for 10 Mbps bandwidth between your two locations which are within the city, they'll charge some money. But if you ask for 50 Mbps, maybe they will time 5 times, right? So here we try to limit the access bandwidth required, and we depend on service providers. Next is WAN, that is wide area network. It connects LANs across cities, like in one company having office, maybe in one in Pune, one in Mumbai, one maybe New York, and you want to connect these offices. You want, because you want what all data is being generated in these offices, you want to see sitting at the head office. So internet is a good medium to connect nowadays, but as we discussed, means of connectivity doesn't matter. It can be through satellite, it can through cable, it can be through wireless, anything. Important thing is how much area you cover in WAN. It can connect to cities, it can connect to countries, continents, doesn't matter. Here also you depend on internet service provider. You will have to request service provider to give connectivity between your offices, that from this office, which has a LAN of its own, another office having its LAN of its own. You want to connect these two offices so that the users from this office can share some of the files, maybe some other resources located in this office. So you want connectivity between these two. That is called wide area network. But we try to limit the bandwidth, because the distance and bandwidth both are the factors that ISP is considered to charge you. Right? If you ask for more bandwidth, more distance to cover, they will charge you more. Then there is another concept of topology. Topology is basically the physical arrangement of computers, how you lay your computers, how you connect your computers, maybe within the premises or maybe any type of LAN. We have discussed LAN, MAN, WAN, doesn't matter, but this is about how computers are connected. So the first one is bus topology, where computers are connected in serial fashion like this. There is only one cable connecting to all the computers. That first computer connected like this, second connected to the same cable, third connected to the same cable, fourth the printer is connected to same cable, right? A scanner connected to same cable. There is only one communication channel for sending and receiving data. Another important thing to notice here is there is a terminator at both the ends. Terminator is required because when you are sending some signals from this computer to another computer on the LAN and there is no recipient, means you don't have the proper address. Suppose by mistake I typed something in a browser www.something.com which doesn't exist, then for what time this request should keep on searching for the destination. This is important. You can't keep it on endlessly, right? So you need something which will terminate the job. So here, if the data which is sent by this computer, destination computer is not found on the network, then it will be terminated or grounded, you can say. So this grounding is important at both ends in bus topology. Unless this grounding is done, you will face lots of problem of collision and signal bouncing. We'll see later. So this bus topology, but it's very simple, easy to build. The advantages: high speed can be achieved because there is only one communication channel and computers are directly connected. Though there is no decision making, it will simply broadcast it, send it on the network, but risky, right? Because this computer will send the message on the network. It doesn't know that where is this computer lying. Suppose I have this computer, third computer, wants to send a message to this one. It will go in both the directions, right? Because it doesn't know it is on my right hand side or left hand side. So this will simply broadcast the message. Any computer having the destination address matching will receive the message, but at the same time others will also receive the message, but they will deny because the address is not matching. Destination address and source address. Source address is something which is sent by the user. So if this is the user who is sending the message, the address of this computer becomes source address, and if I want to send the message to this guy, the address of this computer becomes destination address for me. So I'll send the message using my own address, source address, destination address, so that when I send the message on the network, it will go and ask this computer that do you have this address matching? This says no. It will also at the same time go on this side also and ask this computer, do you have this address matching? This also denies. Then finally it will reach to this computer, where is the destination lying, address is matching. This will accept the message and send back the message to this computer that okay, I have received the message. That's the reason we included source address also, because while sending the acknowledgement signal that I have received the message, how does this computer will send the message back to this computer? This time my source address becomes destination for this computer to send the receipt, and I'll receive the message that okay, this computer has received the message. This is how it works on bus topology or networking. Then we'll discuss about disadvantages of this. Disadvantage is suitable for limited number of computers, that only limited number of computers can be connected because troubleshooting is difficult. Troubleshooting is difficult because now suppose you have 3 computers connected in your network as shown here, right? And I have printer connected, printer and scanner connected to this. Now suppose there is a cable cut here from here. I'll just change the color of pen. For example, there is a cable cut in this area. Now ideally what should happen is this part of the network, this 3 computers and this 2 printer and scanner should be able to talk to each other, right? Because this part of the network is separate from this, because now there are 2 segments of network. One is on the left side and one is on the right side. So we think that these 3 computers should still be able to talk to each other, but they should not be able to print the job because printer is disconnected now or scanner is disconnected. But it doesn't happen like this, because what happens is that you don't have now terminator available or present on the network. Both the networks are splitted. One network is splitted into two different networks, but there are no terminators. Because there is no terminator, grounding will not happen. If this computer will send the message for printing, it will go to this place, it will bounce in this direction again, and will mix up with the incoming signal, and there will be lots of congestion or collision on the network, right? Because there is no terminator, signal is not grounded. Similarly, it will happen on this case also. So when there is a problem in the network, now how do you identify that where is the problem? If there are 50 computers connected like this, and there is a small cable cut somewhere on 48th computer, right? So this part of the cable is cut, maybe for here there is a cable cut, for example. How do I know? Because it's not that only this computer will complain that I am not able to share resources. All of them will complain. Because there is no grounding, complete network will be jammed, right? That is the problem with bus topology. That's why we suggest less number of computers, because it becomes easy to handle, easy to troubleshoot. Now, how to troubleshoot this problem? You will start replacing this segment of cable, this segment of cable, then you will try with this. Every time you replace one segment of cable, you will start the network, ask the user that it's working or not, and unfortunately, out of 50 computers, you will find 48th cable which is faulty. So 48 times you will have to replace the cable, check whether there is a problem or not, because cable cuts are very minor sometimes. It's not visible directly. So this is the case with bus topology, though it is very simple, easy to build, low cost, but not suggested in some cases because troubleshooting becomes very difficult. Let's move on to another topology. Another is star topology. Some of the problems with bus topology we have faced are solved here. That each of the PC, if you observe, each of the PC has separate connection with the central device, right? They are separately connected. It's not connected to one single. There's a something called switch or hub here. It's also mentioned as server in some books, but it's not server. It is switch or hub. We will see what is switch or hub in future. In the coming lectures. So hub or switch is a central device where you can connect different computers, right? So that they become part of the one network. Now here this is my LAN. I have 4 computers and 5th is a server connected to central hub. Now each of this computer has separate connection with my hub. So they have first of all higher bandwidth, because in bus topology I was sharing the bandwidth by using one single cable. There was possibility of only sending signal from one computer to another computer. While these two are talking, others cannot talk to each other because channel is not free, cable is not available, because this computer is already sending signal to another computer. Meanwhile, a third computer cannot start communication with fourth computer. So, but this is not the case with a star topology. Each of these computers separately, this two can be talking to each other, and this two can be talking to each other at the same time in star topology. That is the advantage. So, and it becomes easy to troubleshoot, because here there are separate cable for each computer. If there is a cable cut in this area, only this users will not be able to connect to server, but they can still share the files from this computer to this computer. If I have a printer connected to this, I can send a print job to this computer, though I will not be able to connect to server, but rest of the network still keeps on working. But the problem is, if central device fails, this hub is gone down, some problem with hub or switch, complete network is down. But there are again solutions available nowadays that you can keep 2 switches parallelly and have network running, but costly due to more cable length required, and each of the computer has separate connection with central device. Central device investment is also required. So if central hub fails, network is down. This was star topology. Then you have ring topology, where computers are connected in ring fashion. You can see that these computers are connected like ring. They form a ring. This topology is normally suggested for large networks, WAN networks, because if I have a campus network, that I want some part of the network, instead of looking at this from PC angle, you can see that this is my one building, this is second building, this is third building, and this is fourth building, right? Now in case this part of the cable has some cut, in this case what will happen if it is bus topology? Complete network will be down. If it is my star topology, then also you have central hub, this part of the network will be isolated, some part of the network will be isolated. But here in ring topology, what happens is, if this is my IT department and my servers are placed here, earlier this user or all the users from this building were sending the data through this path, right? Because the ring is being formed here and ring is alive. This user has a choice to send the signal either through this path or through this path. Now in case this ring fails, here there is a cut, this set of users has a choice to send the signal through this path also, right? If the number of users sitting in this department, they were very close to IT department, they used to send the data through this path only, right? Because they are very close to server room, IT department. But in case there is a cable cut here, maybe, then they can send data through this path also. So there is an alternate path always available for sending data, which doesn't cause network failure, right? That is the biggest advantage of ring topology. But costly, because extra cable will be required to cover the space and distance. So mainly suggested for large networks. For smaller networks, they are not useful, and in fact sometimes not required for smaller networks. But yes, if required, you can always do this, and you have alternate path available for sending the data, right? This is how ring is formed. Let's see company network example, right? Here I have a company where there is a building, this building is separate, this building is separate, and this building is separate. Now I have formed ring. There are two rings formed. One is this ring and another is this ring. A reason for this is that these three buildings are separate. 1, 2, and 3 buildings are separate. So I need a ring between these three. If anything goes wrong, suppose the servers are located in this place, you can see this. So if this building, users from this building, there is a cable cut here, they will send the data through this path. This users, if there is a cable cut here, they can send the data through this path, right? So in any case, they have a redundant path available. And within this building also I have a ring, because there are more number of users on each floor. So I want that they should not face problem and they should be able to connect to servers. So this, suppose there is a cable cut here, this set of users on this floor, they will follow this path and will connect to servers. If there is a cable cut here, this users will automatically send the data through this path. So this is how ring network is formed. For larger networks, it is very useful. Next time we'll see transmission medias, that what type of transmission media, means cables or wireless connectivity, how it should be chosen, that what are the benefits of different medias, we'll see. Thank you very much.